All right, the only continuous distribution that you need to know for this or any chapter is the normal distribution. It's also called the bell curve. There is an equation associated with that. You don't need to know what it is, so I'm not even going to give it to you here. You don't need to plug anything into it. It's actually kind of a ridiculous formula. But if you want to know what it is, you're more than welcome to look it up. So what we have here is we have a nice symmetric graph. It's called the bell curve because it does look like a bell. You've got your mean, mu in the middle, and then you've got certain lines that are equally spread out, and each one of them is sigma units away from mu. Remember, sigma is the standard deviation or the square root of the variance. So I want to show you what the probabilities are in each of these sections, if I can remember where I covered them up. Okay, so I've got 34.13% in each of these first sections here that are closest to the mean. Then if I go out one more section, I've got 13.59% in each of those. And then one more section out, I've got 2.15% of the information in that little section. And if I go any further than 3 standard deviations away from the mean, I'm looking at 0.13% of the data there. All right. So just notice that 68% or almost 70% of the information lies, we say, within 1 standard deviation of the mean. So either 1 standard deviation below or 1 standard deviation above the mean. Then you've got all this space within 2 standard deviations of the mean. That is 95.4%. And then a huge percentage between 3 standard deviations from the mean, within 3 standard deviations, 99.74% of your data lies within that range. That only happens, though, if your data is normally distributed. And it always happens, though, when your data is normally distributed. So let's look at an example. Actually, let me go back to this. Let's say I wanted to know, for example, I did give an example. If I have boys that are at a certain high school, they have heights that are normally distributed with a mean of 70 inches and a standard deviation of 4 inches, what percentage of them are between 68 and 78, or 66 and 78 inches tall? So what I did was I put my mean here of 70, and then I went up by 4s because my standard deviation is 4, and I went down by 4s to label the other parts on the x-axis. So if I want the probability or the percent that are between 66 and 78 inches tall, that's this 34.13%, this 34.13%, and this 13.59%. That gets me everything from 66 all the way to 78, and that's a total of 81.85%. If I wanted to do this on a calculator for paper 2, then I'm looking at a function called norm CD. Now there is a norm PD, I think, but I don't ever use it. Normal distributions always talk about a range of data. So to calculate the probability of something being in that range of data, I'm going to need the low end of that range, the high end of that range. I'm going to need to know what sigma is, my standard deviation, and I'm going to need to know what mu is. So if I take that last example, remember my low was 66, my high is 78, sigma was 4, and the mean was 70. And if I plug that in, I get something that's really, really close to what I got before. Remember, I'm only dealing with 3 significant digits, and both times I did get 0.819 if I rounded to 3 significant digits. So that is normal distribution. We're going to talk about a variation on that as far as doing these questions by hand. So it's not as difficult as you might think, but it is something that we do need to go over and have a little bit of practice with. So that's it for today, though, and if you have any questions, let me know, and I will see you tomorrow.